Let us do the in-text question from solution lesson. The first question, calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. So let us write the formula for mass percentage. Mass percentage of benzene is equal to mass of benzene divided by mass of solution, that is mass of benzene plus mass of carbon tetrachloride. Mass of benzene plus mass of carbon tetrachloride into 100. So that is equal to 22 by 22 plus carbon tetrachloride, it is 122 into 100. So that is equal to 22 by 144 into 100. When we simplify, we will get 15.28 percentage. Now for calculating mass percentage of carbon tetrachloride, we know percentage is expressed out of 100. So mass percentage of carbon tetrachloride means 100 minus 15.28 percentage, that is equal to 84.72 percentage. Question, calculate the mole fraction of benzene in solution containing 30 percentage by mass in carbon tetrachloride. So percentage by mass of benzene is given. So we know the percentage is given means mass of solution is equal to 100 gram. Mass of solution is equal to 100 gram. And here 30 percentage benzene is present means mass of benzene equal to 30 gram. Therefore mass of carbon tetrachloride will be the remaining percentage, that is mass of carbon tetrachloride is equal to 100 minus 30 gram, which is equal to 70 gram. So now we know the masses of all components. Now let us calculate. For mole fraction, we need number of moles of each component. So number of moles of benzene is equal to mass of benzene by molar mass of benzene. Mass of benzene is 30 gram. Now we have to calculate the molar mass of benzene. We have 6 carbon atom. So atomic mass of carbon is 12. 12 into 6 plus hydrogen atomic mass 1. 1 into 6. Okay. So we will get 72 plus 6, 78 gram. So 78 gram per mole, that's the molar mass. So 30 by 78, when you simplify, you will get 0.3846. So we can write it as 0.385 moles. So number of mole of benzene we got. Now similarly, we can calculate number of moles of carbon tetrachloride. Number of moles of carbon tetrachloride. So mass of carbon tetrachloride is 70 gram divided by molar mass of carbon tetrachloride. 1 chlorine, its mass we can take it as 35.5, and we have 4 chlorine atom. So we have a mass of 142 for 4 chlorine and 12 for carbon. So we have 154. That's the molar mass of carbon tetrachloride. So 70 by 154 we will get, when you simplify, you will get 0.455 mole. Now we got the number of moles of both the components. Now we know mole fraction of benzene is equal to number of moles of benzene divided by number of moles of benzene plus number of moles of carbon tetrachloride. Now let us substitute the value we got. Number of moles of benzene is 0.385 and divided by 0.385 plus 0.455. So when you simplify, you will get 0.385 divided by, when we add this, we will get 0.840. And then now you will get the mole fraction as, when you simplify, you will get the answer as, denominator is bigger. So your answer is 0.458. 0.458 is the mole fraction, and mole fraction has no unit because it's a ratio. Calculate the molarity of each of the following solution. We know molarity is equal to number of moles of the solute divided by volume of the solution in liters. So for number of moles, we can expand number of moles. Mass of solute divided by molar mass of solute. Mass of solute divided by molar mass of solute divided by volume of solution in liters. Here mass of solute is given as 30 gram. But molar mass we don't know. Let us calculate molar mass first. Cobalt nitrate CONO3 twice dot 6H2O. Let us calculate molar mass of cobalt nitrate. So molar mass of cobalt nitrate, cobalt first let us write the atomic mass. Cobalt atomic mass is 58.93. We have 2 nitrogen atom, 2 into 1428. We have 6 oxygen atom, so 16 into 6. Plus 6 water molecule, 6 into 18. So when you simplify all this, you will get 290.93. We can approximately take it as 291 also, no problem. 290.93 gram per mole. Now volume already given in liters, so no need of any conversion. 4.3 liter is given. So now we know everything. So let us calculate molarity. Molarity is equal to 30 divided by 290.93 divided by volume of solution in liters. So 30 divided by 290.93 into 4.3. So when you simplify, you will get approximately 0.0239. So 239 you can take it as 24 also. This much molar. So this is the molarity of the first solution. Then second part of the question, 30 ml of 0.5 molar sulfuric acid diluted to 500 ml. So you can use the dilution formula, that is initially what is the molarity, M1V1 equal to M2V2. Initially we know the volume V1 as 30 ml. So V1 equal to 30 ml and it is diluted to 500 ml. So V2 is equal to 500 ml and initial molarity M1 is equal to 0.5 molar. We don't know M2. So we can just equate and find out M1 V1 equal to M2 V2. So 0.5 into 30 is equal to m2 into 500. So therefore m2 is equal to 0.5 into 30 divided by 500. So when you simplify, you will get 0.03 molar. The same question, suppose if you don't know the formula m1v1 equal to m2v2, you can use the other molarity formula itself, or you can calculate number of molarity is equal to number of moles divided by volume of solution in liters, this formula. From this you can find out the number of moles. So number of moles is equal to molarity into volume of solution in liters. Molarity into volume of solution in liters. So we know initially the molarity is given as 0.5 and volume is 30 ml. So you can convert into liters by dividing using 1000. So you will get 0.5 into 0.03, which is when you multiply you will get 0.015 mole. So this is the number of moles. Then second case, it is diluted to 500 ml. So volume in liters, volume is equal to 500 ml. We can convert into liters by 1000. So ml will be converted to liter. So you will get half liter or 0.5 liter. 0.5 liter for converting, we divided by using 1000. Now molarity is equal to number of moles. Already we know the number of moles, same solution only, 0.015 divided by 0.5. So you will get 0.03 molar. Molar or mole per liter. Both the ways you can use, anyone which seems to be easy you can apply. Next question, calculate the mass of urea required in making 2.5 kilogram of aqueous solution. So mass of solution required is 2.5 kilogram. Mass of solution is equal to 2.5 kg. That means 2500 gram solution you have to prepare. And molality of the solution is given 0.25 molal. 0.2 small letter m represent molality. 0.25 molal means 0.25 moles urea is present in 1000 gram water. So we can expand molality and we can find out the mass of urea present in 1000 gram of water. Molar mass of urea is equal to, from the formula NH2CO NH2, we have 2 nitrogen atoms, so 14 into 2, plus we have 1 carbon atom, so 12, and we have 4 hydrogen atom, 4 into 1, 4. So we will get a total of 60 gram per mole. So number of moles is equal to mass over molar mass. Number of moles it is given in the question. So mass is equal to number of moles into molar mass. Number of moles which is equal to 0.25 and molar mass is 60. So when we simplify this, you will get 15 gram. So 15 gram of urea is present or dissolved in 1000 gram of water. So the total mass of solution is equal to mass of solution is equal to mass of solute. Solute is urea 15 gram plus mass of solvent. So 1015 gram. So 1015 gram solution contains 15 gram urea. Therefore 2500 gram of solution contains how many grams of urea? You can just do by unitary method. 1015 gram solution contains 15 gram urea. Therefore 2500 gram solution need how many gram of urea or requires 15 divided by 1015, that's for 1 gram, then for 2000 gram 2500 gram into 2500. So when you simplify this, you will get 36.95 gram. So this is the amount of urea required for preparing 2500 gram of solution. Question: calculate molarity and mole fraction of potassium iodide if the density of 20% aqueous potassium iodide solution is given. So it is 1.202. So first part of the question, you have to calculate molality. Molality is equal to number of moles of the solute. Molality is equal to number of moles of the solute, that is mass of solute divided by its molar mass the whole divided by mass of solvent in kg. Now let us find out each term. Mass of solute, that is mass of potassium iodide. Potassium iodide is our solute. That is 20% mass by mass means 20 gram of benzene is present in 100 gram of solution. So any percentage question is given, mass of solution is fixed, it is 100 gram. Then mass of solvent or solution is aqueous. So mass of solvent means here mass of water, which is equal to 100 minus 20, that is equal to 80 gram. Now next let us see molar mass of potassium iodide. Molar mass of potassium iodide. Atomic mass of potassium is 39.1 and iodine is 126.9. So when we add this two, you will get 166 gram per mole. Now we know all the terms. Molality is equal to mass of solute 20 divided by molar mass 166 divided by mass of the solvent is 80 divided by 1000. So when you simplify this, you will get a molality of 1.5 molal. Now let us do the second part of the question, molarity. So we know what is molarity. For calculating molarity, we don't have volume of solution. So we have to find out the volume of solution. For that, density of solution is given. Density of solution is given as 1.202 gram per milliliter. And volume of, for finding volume, we know before we wrote mass of solution is always fixed, it is 100 gram. So therefore mass by volume is equal to density. Since mass by volume is equal to density, so we have to find out volume. So volume is equal to mass by density. Volume of solution is equal to mass by density. Mass of solution is 100 and density is 1.202. So when you simplify, you will get 83.2 ml. This is the volume of solution. Now, next directly we can go to molarity. Molarity is equal to mass of solute. Mass of solute is 20 gram. Then molar mass of solute, potassium iodide molar mass we already calculated. It is 166 divided by volume of the solution, we got it as 83.2, then divided by 1000 for converting into liters. So we will get the molarity of solution as 1.44 molar. Then, or alternatively, a simple method is there. Direct, if you memorize the formula, we can directly do this calculation. Molarity is equal to mass percentage of the solute into density of solution into 10 divided by molar mass of solute. So mass percentage is given in the question as 20 and density 1.202 into 10 divided by molar mass of the solute is 166. So you will get approximately 1.44 molar. Okay. Then third part of the question, calculate mole fraction. Calculate mole fraction of potassium iodide. For that, mole fraction is equal to number of moles of potassium iodide divided by number of moles of potassium iodide plus number of moles of water. Solution means solute plus solvent. So number of moles of potassium iodide, we already calculated that. Mass by molar mass 20 by 166, then again 20 by 166 plus number of moles of water, and water, its mass is 80 divided by 18. So when we simplify this, 20 by 166, you will get 0.120 divided by again 0.12, 80 by 18, you will get 4.44. So finally we will get 0.0263. This is the mole fraction. So mole fraction has no unit, but molarity is molar or mole per liter, and molality is molal, small m, or mole per kilogram. Next question. H2S, a toxic gas with a Rottenegg-like smell, is used for the qualitative analysis. If the solubility of H2S in water at STP is 0.195 molal, calculate Henry's law constant. So here molality is given 0.195 molal. That means 0.195 mole H2S is dissolved in 1000 gram of the solvent. 1000 gram H2O, solvent is water. So number of moles of H2S is equal to 0.195. Number of moles of water is equal to 1000. Mass of water is 1000 by molar mass is 18, so it's a constant 55.55. Now, mole fraction of H2S is equal to number of moles of H2S divided by total number of moles, that is number of moles of H2S plus number of moles of water, which is equal to 0.195 divided by 0.195 plus 55.55. That will be equal to 0.195 divided by, when we add this, we will get 55.745, which is equal to 0.0035. That's a mole fraction. Now, according to Henry's law, we know P is equal to Kh into chi. And the solubility, the Henry's constant, for calculating Henry's constant, we can write P by chi. Here, pressure of gas at STP. Pressure is equal to, at STP, the pressure of gas is equal to 1.013 bar. So that is equal to 1.013 divided by 0.0035, which is equal to, when you simplify, we will get 289.4 bar. Now let us move to the next question. Henry's law constant for carbon dioxide in water is 1.67 into 10 raised to 8 Pascal. This is 10 raised to 8 only. At 298 Kelvin, calculate the quantity of carbon dioxide in 500 ml of soda water when packed under 2.5 atmosphere carbon dioxide pressure at 298 Kelvin. So pressure of carbon dioxide is given as 2.5 atmosphere. And Henry's constant is given as 1.67 into 10 raised to 8 Pascal. So for converting atmosphere into Pascal, we have to multiply with the 10 raised to 5. So that much Pascal we will get. Now, according to Henry's law, partial pressure of carbon dioxide is equal to Kh into chi. So, mole fraction of carbon dioxide is equal to partial pressure of carbon dioxide divided by Kh. Partial pressure of carbon dioxide is 2.5 into 10 raised to 5 Pascal divided by the Kh value is 1.67 into 10 raised to 8. So when we simplify this, we will get 1.497 into 10 raised to minus 3. So you can take approximately, this will be equal to, you can take it as 1.5 into 10 raised to minus 3. Now, next we have to calculate the mass of water. We know mass by volume is equal to density. Here density is not given, so you can take the density as 1 gram per ml. So in such case, mass and volume will be equal. So mass of water is equal to 500 ml, that is equal to 500 gram, because we are taking density as 1. Now, number of moles of water is equal to, we have 500 gram mass by molar mass. So that will be 27.78 mole. Now let us calculate the mole fraction of carbon dioxide. Mole fraction of carbon dioxide is equal to number of moles of carbon dioxide divided by total number of moles. Number of moles of carbon dioxide plus number of moles of H2O. We can neglect the number of moles of carbon dioxide from the denominator. So, number of moles of carbon dioxide is equal to, now we can cross multiply mole fraction of carbon dioxide into number of moles of water. So mole fraction of carbon dioxide, we already got 1.5 into 10 raised to minus 3. And number of moles of water also we know 27.78. So when we multiply, we will get a value of 41.67 into 10 raised to minus 3 mole. Now they told us to calculate the quantity, so we can convert the number of moles into mass. Number of moles is equal to mass over molar mass. So mass of carbon dioxide equal to number of moles into molar mass. So mass equal to number of moles 41.67 into 10 raised to minus 3 into molar mass of carbon dioxide. It is 12 plus 32, which is equal to 44. 2 oxygen, 2 into 16, 32. So 44. Then when we multiply, we will get 1.834 gram. Question. The vapor pressures of pure liquids A and B are 450 mm and 700 mm of mercury respectively at 350 Kelvin. Calculate the composition of the liquid mixture if the total vapor pressure is 600 mm of mercury. Also find the composition of the vapor phase. So according to Rolle's law, we can write P total is equal to P0 A chi A plus P0 B chi B. Now total vapor pressure of the over the solution we can relate to mole fraction of any one component, since we know 1 minus chi A is equal to chi B. So P total is equal to P0A plus P0B minus P0A into chi B. Now let us substitute the values. The vapor pressure of pure liquid A, P0A, that is 450 mm. So 450, and P0B is 700. P0A is 450 into chi B, which is equal to P total. So 600 minus 450, which is equal to 700 minus 450, that is 250 chi B. So 150 by 250 is equal to chi B. When we simplify, we will get chi B is equal to 3 by 5, which is equal to 0.6. Now we got the mole fraction of liquid B. Now chi A is equal to 1 minus chi B. So 1 minus 0.6, which is equal to 0.4. Now we got the mole fraction of each component. Now let us find out the partial pressure of the first component. PA according to Rolle's law, PA is equal to P0A chi A. So PA is equal to P0A is 450 millimeter of mercury and chi A is 0.4. So when you multiply, you will get 180 millimeter mercury. Similarly, we can do for PB also, second component. PB is equal to P0B chi B. Now P0B is 700 and chi B is 0.6. So when you multiply, you will get 420 millimeter mercury. Now we got the pressures of the individual component. Now next you have to calculate the mole fraction of each component in vapor phase. For that, we know now in vapor phase, mole fraction of each component in vapor phase. So YA is equal to PA by P total. Now we already calculated PA, that is equal to 180 divided by total means 420 plus 180, that is 600. 180 plus 420, 180 by 600, which is equal to 0.3. Then next component YB equal to 420 PB by total, that is 180 plus 420, that is equal to 420 by 600, which is equal to 0.7. Question: vapor pressure of pure water at 298 Kelvin is 23.8 millimeter mercury. 50 gram of urea is dissolved in 850 gram of water. Calculate the vapor pressure of water for this solution and its relative lowering. So here vapor pressure of pure solvent is given as 23.8. So P10 is equal to 23.8 millimeter mercury. Then mass of solute is given as 50 gram. Molar mass of solute, urea is our solute, so NH2CO, NH2, 2 nitrogen, 2 into 14 plus 4 into 1 plus 12 plus 16. When we simplify, we will get 60 gram per mole. Then next, mass of solvent is given as 850 gram. So when we apply Rolle's law, P10 minus P1 by P10 is equal to chi2. Chi2 when we expand, we will get N2 by N1 plus N2. So P10 is given as 23.8 minus P1 by P10 is equal to 50 by 60 divided by 50 by 60 plus 850 by 18. So when we simplify this, we will get 0.017. Now 23.8 minus P1, here P10 also we can write 23.8 itself, so which is equal to 0.017. 23.8 minus P1 equal to 23.8 into 0.017. So when you multiply 23.8 into 0.017, we will get 0.4046. So P1 equal to 23.8 minus 0.4046, which is equal to 23.4 millimeter mercury. So vapor pressure of water in the solution is equal to 23.4 millimeter. Boiling point of water at 750 millimeter of mercury is 99.63. How much sucrose is to be added to 500 gram of water such that it boils at 100 degree Celsius? So mass of water is given as 500 gram. Molecular mass of sucrose M2, its formula is sucrose C12H22O11. C12H22O11. So we have 12 carbon, 12 into 12, 144 plus 22 hydrogen, 22 into 1 plus 16 into 11. When we simplify, we will get 342 gram per mole. Then next elevation of boiling point delta TB is equal to TB minus T0B. That is boiling point of solution minus boiling point of pure solvent. Boiling point of solution is 100 degrees Celsius. TB is equal to 100 degrees Celsius and T0B is equal to 99.63 because elevation of boiling point. So TB minus T0B 100 minus 99.63 degrees Celsius. So we will get 0.37 degree Celsius. So this is difference. Because of that we can write it as 0.37 degrees Celsius equal to 0.37 Kelvin. Now let us substitute in the formula delta TB is equal to Kb into molality. Molality is equal to mass of solute divided by molar mass by mass of solvent in kg, that is into 1000 W1. So let us substitute in the formula. Kb for water it is equal to, that will be given in the question. Normally they used to give in the question the value of Kb. It is 0.52. Kb for water it is 0.52. So 0.52 into mass of solute that you have to find out into 1000 divided by 342 into mass of solvent 500, that is equal to 0.37. So when we simplify we will get W2 is equal to 0.37 into 342 into 500 divided by 0.52 into 1000. When we simplify this we will get 122 gram. Next question. Calculate the mass of ascorbic acid to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. So delta TF is given. It is 1.5 degrees Celsius, that is equal to 1.5 Kelvin. Then mass of solute that you have to find out. W2 we have to find out. Then W1 is equal to 75 gram and molar mass of solute, it is ascorbic acid, vitamin C, C6H8O6. So 12 into 6 plus 8 into 1 plus 16 into 6. When we simplify this we will get 176 gram per mole. Next, Kf is given as 3.9 Kelvin kilogram mole raised to minus 1. So delta Tf is equal to Kf into molality, mass of solute by molar mass, all divided by mass of solvent in kg. So when we take reciprocal we can write the equation like this. Now let us substitute. 1.5 is equal to 3.9 into mass of solute that we don't know. So we can write it as W2 into 1000 divided by molar mass 176 into mass of solvent is 75. So W2 is equal to 1.5 into 176 into 75 divided by 3.9 into 1000. So 5.079. So we can write it as 5.08 gram. Then next question. Calculate the osmotic pressure in Pascal exerted by a solution prepared by dissolving 1 gram of polymer of molar mass 1,85,000 in 450 ml of water at 37 degree Celsius. So we have to calculate the osmotic pressure pi. We know pi is equal to CRT. Here C stands for molarity, that is number of moles divided by volume of solution in liters. So first let us calculate the number of moles of the solute. So N2 is equal to number of moles is equal to mass of the solute by molar mass, W2 by M2. Here mass of the polymer it is 1 gram and molar mass of the polymer is 1,85,000. So when we simplify this, we will get 1 by 1,185,000. We can substitute in the equation as it is, or we can simplify this. Then pi is equal to 1 by 1,85,000. That's the number of moles. Then R value, R is equal to 8.314. Here the value joule per Kelvin per mole, or we can write 8.314 into 10 raised to 3 Pascal liter Kelvin raised to -1 mole raised to -1. So let us substitute 8.314 into 10 raised to 3. Then temperature is 37 degrees Celsius. When we convert into Kelvin scale, 37 plus 273, which is equal to 300 Kelvin. So let us substitute that value here, 300 Kelvin. The osmotic pressure in Pascal exerted by a solution prepared by dissolving 1 gram of polymer of molar mass 1,85,000 in 450 ml of water at 37 degree Celsius. So osmotic pressure formula pi is equal to CRT, where C is molarity, that is number of moles divided by volume of solution in liters. Volume is given as 450 ml. Mass of solute is equal to 1 gram. Molar mass of solute is equal to 1,85,000. Temperature is given as 37 degrees Celsius. So we can convert into Kelvin by adding 273. So 310 Kelvin. Now pi is equal to C, number of moles, mass over molar mass, divided by volume of solution in liters. So 450 by 1000 into R is the gas constant, that is 8.314 into 10 raised to 3 Pascal liter Kelvin raised to -1 mole raised to -1. So R equal to 8.314 into 10 raised to 3. We have to do the answer in Pascal and temperature is 310. So 1000 by 1,85,000 into 450 into 8.314 into 10 raised to 3 into 310. That is equal to, when we simplify, we will get 30.96 Pascal.